Welcome students. In today's class, we will be going through another capsule of the topic 125 MCQs and last minute revision for your end semester examination. And this capsule will be covering the topic on friction. So as usual, let us first start with the LMR of this topic, friction. So starting with what friction is. So friction is a force that resists the sliding or rolling of one body over another. Then let us go and study what are the different laws of friction. So the first law of friction is when an object is moving, the frictional force is proportional and perpendicular to normal force. So the friction force will be always proportional and perpendicular to the normal force. It is a tangential to the surface and opposite to direction of motion. So its direction will be always opposite to that of direction of motion, and it will be tangential to the surface or perpendicular to the normal force. So the second law is it is independent of area of contact. So friction does not depend on area of contact. Third, the coefficient of static friction is greater than the coefficient of kinetic friction. So I can write down mu s is greater than mu k. Next, depends on the nature of contact surface. The next is the ratio of limiting frictional force to the normal reaction is constant and is known as coefficient of friction. So coefficient of friction is defined as the ratio of limiting force. So limiting friction force is mu n to the normal reaction. So you can write down this FR, it is limiting friction force divided by n. And this quantity is constant and is known as coefficient of friction. What is angle of friction? That is phi. So the angle between the normal and the resultant of normal and frictional force is known as the angle of friction. So in the diagram you can see that there is normal here, the normal force, and it's the resultant force. Resultant of what? It is resultant of this limiting friction force and the normal reaction. You can see here the angle phi. This is the angle between the resultant and the normal force. And resultant of what? Resultant of normal and the friction. Next is angle of repose denoted by theta. So angle of repose is defined as the minimum angle at which the body starts to slide down the plane without any application of external force. So let us say here there is a body of weight W and it is kept at angle, some angle theta. Now as we go on increasing the angle, at some angle this body will start moving down on its own without any application of external force. So that angle at which it slides on its own is known as angle of repose. Is there any relation between angle of repose and angle of friction? Yes, there is relation that theta is equal to phi. That is angle of repose is equal to angle of friction. So we have, if you do the derivation for this, we get u is equal to tan of phi. Here also if you derive, you get u is equal to tan of alpha. So if both the left hand side are equal, I will get tan phi is equal to tan of alpha. So tan inverse on both side if I take, so tan and tan will get cancelled and I will get phi is equal to alpha. That is angle of friction is equal to angle of repose. Next, that is cone of friction. It is defined as an imaginary cone. Okay, it is an imaginary cone formed by revolving the resultant of the resultant. So if we revolve this resultant of a normal reaction and the limiting friction force about the normal reaction for one complete revolution. So this was all about. I want to give you the LMR for this topic. Now let us start with the MCQ part of this. The first question is a body of weight 500 Newton is pulled up along an inclined plane having angle of inclination 30 degrees. Okay. So this is the plane. It inclined at 30 degrees, and there is a block of weight 500 Newton per, and it is pulled up. It is pulled up by a force that is, let us say, it is P. If the coefficient of friction between the body and the plane is 0.3, so if this is 0.3 surface friction, and the force is parallel to inclined plane, so I have made it parallel to inclined plane. What will be the force required to maintain the equilibrium? So we need to find out this force. So let's first draw the free body diagram. So in free body diagram, what we draw? First we draw the applied forces. The applied force. Then we make the self weight. So self weight is given as 500 Newton. Then we make the reaction from contact surface. So as the surface is inclined here, reaction will be perpendicular to it. It will be like this from surface to the body, let it be N. And then next will be the friction force. So as the body is moving towards up the plane, the friction force will act downward the plane. Mu multiplied by N, value of 0.3, will be 0.3 N. Now if you observe, if I consider this as my coordinate system X and Y, only inclined force is this one, that is 500 Newton. So I will draw one line parallel to X, one line parallel to Y, resolving the base component. So this will be 500 cos of 30, because angle will be 30, and this will be 500 sin. So after drawing the free body diagram, next will be apply the conditions of equilibrium. So I will have summation of Fx is equal to 0. So in Fx, there is one force going left side, so it will be minus P. Then it is going right side, so it will be positive. Add all the forces in X direction. So first force which I can counter is this one, P. It's going right side, so it will be positive. Then this is going towards left side, so negative. So minus 0.3 N. Then this force also going towards left side, so it will be minus 500 sin 30. And this all should be equal to 0. So from this equation, there are two unknowns, P and N. So we will not get answer. That is equation number 1. Now go for summation of Fy is equal to 0. So for Fy, I have two forces, N going upwards, so it will be positive, minus 500 cos 30 is equal to 0. So from here, I will get therefore N is equal to 500 cos 30. Now put this value of N in this equation 1, so I will get therefore P minus 0.3, in place of N I will write 500 cos 30 minus 500 sin 30 is equal to 0. Now only unknown in this equation is, so solve this and get the answer for P 380 Newton, which is option number C. This is the correct answer. Next question. A body of weight W is required to move up a rough inclined plane whose angle of inclination is horizontal is alpha. So almost similar problem but without values. So there is up the plane, angle is alpha given, and there is a weight, body of weight W here. It is applied force is parallel to the plane, and we want the value of P such that it is in equilibrium. So again, same, first I will draw the free body diagram. So for a free body diagram, first is the applied force, then it will be self weight, then it will be reaction from contact surface, and then finally it will be a friction force, which will be mu into N. Mu into N. So now this is the inclined force, so I will resolve it. So this will be W cos alpha, this is alpha, and this is W sin alpha. If I write summation of Fx is equal to 0, I will get P minus W sin alpha minus mu N is equal to 0. That is equation number 1. And if I go for the second equation, I will get summation of Fy is equal to 0. So from here I will get N minus W cos alpha is equal to 0. I will get N is equal to W cos alpha. So put this value of N in this equation, so I will get therefore P minus W sin alpha minus mu into n, that is w cos alpha is equal to 0. If I want p, it will be p is equal to w sin alpha plus mu into w cos alpha. So if I take w common, so it will be p is equal to w sin alpha plus mu cos alpha. So if I go for the answer, it will be yes. Option number A. Option A is the correct answer. Next question. Which one of the following is true? So the tangent of coefficient of friction. Tangent of coefficient of friction means tan of mu is equal to angle of friction phi. No, it is wrong. Phi is tan inverse of mu. So it's wrong. We have phi is tan inverse of mu. This is wrong. Then the angle of repose is always greater than angle of friction. No, it is equal. The angle of repose is less. No, it is not less. Limiting frictional force is directly proportional to normalization. Yes, this is the correct one. We have seen it in the laws of friction. So this option is correct. Option B. Next question. A body of 800 Newton kept on a rough incline at 10 degrees. Okay, that's the body kept at rough incline of 10 degrees and the value is 100 Newton. If horizontal is at rest, if the coefficient of friction is 0.3, if coefficient of friction is 0.3, determine the frictional force. N will be like this. If I draw the free body diagram, this is the applied force is not there. This will be self-shift. This will be normal reaction N, and the friction force will be like this. If I assume that this body is moving downwards, friction force will be upwards. That is mu. If this is 100 Newton and this is 10 degrees, so this will be 100 cos of 10. This will be 100 sin of 10. If I apply condition to equilibrium here, I will get n minus 100 cos 10 is equal to 0. So I will get n is equal to 100 cos 10. Just substitute here, therefore I will get frictional force is equal to mu. That is 0.3 and n we got 100 cos 10. If I solve this, I will get answer as 29.54. This is option number A. This is the correct one. Next question. A massless ladder is kept on a rough floor. There is a ladder kept on a rough floor. So there is coefficient of friction here present and against a rough vertical wall. So here also the wall is rough, so here also some coefficient of friction. In this case, ladder will remain in stationary position, slide downwards along the wall and horizontally along the floor, rotate about the vertical axis, rotate about the horizontal axis. So as there is friction available on both the sides, as there is friction available on both the sides, at the wall as well as on the floor, and there is no load acting on this ladder, I can say that the ladder will remain in the stationary position. The answer should be option A. Next is force of friction acts in the direction dash to the direction of motion. We all know that friction of force directly. We all know that friction force acts opposite to the direction of motion. So it will be option number A. Next question. The coefficient of friction does not depend on mu. Does not depend on it is asked. So it is area of contact, weight of the body, nature of surface, and normal reaction. So in the laws of friction only we have seen that it does not depend on area of contact. So answer will be option. Next question. The angle which the inclined plane makes with the horizontal when the body is placed on it about to move down on its own is known as. So for a definition of angle of repose, we have seen this, that if the body slides on its own with some angle theta, then it is known as angle of repose. So the answer will be option number C, angle of repose. Next question. The angle made by the resultant of normal reaction and the frictional force with the normal reaction at the point of impending motion is called. This entire thing is nothing but a definition for angle of friction. It will be option number A. A body of weight 100 Newton is kept on rough inclined plane at 20 degrees with horizontal. Is in the verge of motion. The coefficient of friction is it is 100 Newton body and there is a 20-degree inclined force and we need to find out what is mu. Now just observe this. Most of you what to do? We start doing calculations. Just remember the formula. Just remember the statement for angle of repose. Here there is no force applied, and it is telling that it is in the verge of motion. That means the motion is just starting on its own. That means this angle is angle of repose. So if this is angle of repose, I can directly write mu is equal to tan of that is angle of repose. So I will get mu is equal to tan of 20 degrees, which I will get answer as 0.363. So the answer is option number C. Friction force depends on friction force depend on area of contact surface. No, it does not depend on shape of body. It depends on normal reaction. Yes. In the laws of friction also we have seen the friction force depend on normal reaction. Next is if a disc is rolling without slipping on a rough horizontal surface by an applied force F at tangentially at the top of the disk towards right, pick the correct option. The scenario is like this: there is a floor, rough floor, and there is a disk which is rolling without slipping, and there is a tangential force acting here, which is towards right side. And we have to see what is the there is no friction, so this is the not the option because it is a surface. Friction should be there. Static friction is the right direction of the floor. There is no question of static friction because the body is moving. So static friction is already overcome. So this is not the option. Again, it is given static friction. So this is also not an option. So the only option remaining is this one. That is kinetic friction is in right direction of the floor, which is also an correct option logical. Next question. Coefficient of friction is okay. Coefficient of friction is just the definition he has asked. Angle between the normal reaction and the resultant of normal reaction and the limiting friction. Ratio of limiting friction and normal reaction. Yes, this is the correct answer. We have seen that mu is equal to the ratio of the limiting friction force to the normal reaction. That is the correct answer. Next question. What is relation between angle of repose and angle of friction? This also we have seen that phi is equal to theta, that is both are equal. So it will be angle of friction equal to angle of repose option. But a 300 Newton block is resting on rough horizontal surface for which coefficient of friction is 0.5. Find the force P required to implement the motion if P is acting horizontally. So there is a block of 300 Newton resting on the surface of mu is equal to 0.5, and you want what is the horizontal force P to start this motion. So again same, I will draw the free body diagram. So applied force is P, then shell plate is 300 Newton, then there is reaction from contact surface, so this is N, and friction force. So as I am assuming that this body is moving towards right side, friction force will be towards left side with a value of mu N. Now if I apply condition of equilibrium, I will get P minus mu N is equal to 0, or I will get therefore P is equal to mu into N. And in this, if I apply summation of Fy is equal to 0, I will get N minus 300 is equal to 0. So I will get N is equal to 300 mu. If N is 300, putting this value of putting this value of N in this equation, I will get therefore P is equal to mu, that is 0.5 divided by 300. So the answer will be 150 Newton. Option is option number C. Next question. Coefficient of static friction, that means mu S, is less than coefficient of kinetic friction? No. Is greater than coefficient of limiting friction? Is equal to coefficient of dynamic friction? Is equal to tangent of angle of friction? So we have studied that mu S is greater than mu Q. So this option is not available here, but we have the option like this: is equal to tangent of angle of friction. The tangent of the angle of friction, it is phi. So mu is equal to tan phi is the correct relation. This is the answer for option C. So with this, we have completed the topic of friction, and in the next class, I will be starting with the topic on kinematics of rigid bodies. Thank you.